Welcome to AI News Digest 2026-06-23. Today's 9 stories. Story 1, Large Reasoning Models as Thinking Machines for Medicine. Story 2, in LLM Reasoning there is irrationality on top of value misalignment. Story 3, how Yann LeCun's startup challenges the logic behind today's LLMs. Story 4, PEAR, Permutation-Equivariant Adaptive Routing Multi-Agent Debate. Story 5, Beyond Fixed Budgets, Characterizing the Inelasticity and Limitations of Tree of Thought Reasoning Strategies. Story 6, GOOG down -6% today due to 2 top AI researchers departing. Story 7, SkillHarness, Harnessing Safe Skills for Computer Use Agents. Story 8, Darwin Mobile Agent, a Roadmap for Self-Evolution. Story 9, Specifying AI-SDLC Processes, a Protocol Language for Human-Agent Boundaries. Story 1, Large Reasoning Models as Thinking Machines for Medicine. As artificial intelligence agents take on increasingly active roles in software development, a critical question has gone largely unanswered. How do you formally specify where human responsibility ends and AI agent authority begins? That is the problem a new paper by researcher Ili Prifty attempts to solve, proposing a domain-specific protocol language for what he calls the AI software development lifecycle, or AI-SDLC. The core problem Prifty identifies is one that anyone who has worked with AI-assisted engineering will recognize. Today, the rules governing what an AI agent is allowed to do when it needs human approval and who is accountable for its outputs are typically encoded in prompts. And prompts are fragile. They drift over time, they can be misinterpreted by models, and they provide no structural guarantee that governance constraints will actually be enforced. Prifty argues that what we need instead is a formal specification language, one that can express human-agent responsibility boundaries, approval gates, and capability limits in a way that is structurally enforced rather than merely hoped for. The paper introduces several key contributions. First, it distinguishes between policy, what you intend the process to do, and mechanism, what the system structurally enforces. This distinction turns out to matter enormously for reliability. When governance is structurally enforced, the paper shows mathematically that system failure rates are bounded by a weighted product of individual agent and validator failure rates, meaning they stay low. When governance is only behavioral, meaning prompt-based, failure rates can accumulate cumulatively, potentially reaching near saturation. That is a stark formal difference. Prifty also introduces what he calls the 2+N team pattern, which formalizes classical separation of duties for AI-augmented teams. 2 human roles maintain control. Think of them as the approver and the auditor, while N specialized AI agents handle the actual work. This maps directly onto real engineering team structures and existing compliance frameworks in regulated industries. Now, the paper is explicitly a position paper with no empirical validation yet. The companion study and open-source implementation are promised but forthcoming, so the gap between elegant formal theory and messy real-world agent behavior remains open. But for organizations trying to build governance frameworks for AI in software development, this paper offers something valuable: a rigorous vocabulary and a tractable formal approach to a problem that most teams are currently solving with hope and good intentions. Story 2. In LLM Reasoning, there is irrationality on top of value misalignment. As AI agents that can actually operate computers, clicking through interfaces, filling out forms, navigating web pages, move from research prototypes into real deployments, a fundamental safety question has been lurking in the background. What happens when these agents learn bad habits? A paper published on Archive in June 2026 from researchers Yurun Chen and colleagues proposes a framework called SkillHarness to answer that question. Here is the problem they are solving. Modern computer use agents, or CUAs, get better over time by abstracting reusable skills from successful past interactions. See a task done correctly, store it as a skill, replay it later. That sounds great in a lab environment where everything is controlled and predictable. But the real world has adversarial content. Think web pages with hidden instructions designed to hijack the agent's behavior, a technique called prompt injection. And it has ordinary chaos like pop-up dialogues, session timeouts, and UI changes. Current skill learning approaches have no mechanism to distinguish a skill learned from a genuinely good trajectory from one that succeeded by accidentally following a malicious instruction. Those corrupted skills then sit in the agent's library, waiting to cause harm. SkillHarness introduces what the authors call a skill boundary, a mechanism that uses multiple sources of supervision signals to evaluate whether a skill is actually safe before it enters the reusable library. Crucially, safety constraints are not set once and forgotten. They evolve throughout the skill's entire life cycle, because a skill that was safe last month might be dangerous in a changed environment. The framework also introduces selective skill reuse, meaning the agent does not just dump its entire skill library at a problem. It decomposes the task and activates only the relevant subset of skills, reducing the attack surface. The results are significant. SkillHarness reduces the unsafe rate of learned skills by 57.1% compared to existing baselines and improves execution stability under dynamic environmental conditions. The paper spans not just AI and machine learning literature, but also cryptography and security, which tells you something about how seriously the authors take the adversarial threat model. Why does this matter beyond academic interest? Because enterprises are actively evaluating computer use agents for automation of knowledge work. A single unsafe skill execution in that context could mean unauthorized transactions, data exfiltration, or irreversible file deletion. SkillHarness is work in progress, and the specific baseline comparisons need more transparency. But the direction it points, treating skill safety as a continuous, life cycle-aware engineering challenge rather than a one-time filter, is exactly the right frame for making CUAs deployable in the real world. Story 3. How Yann LeCun's startup challenges the logic behind today's LLMs. There is a recurring debate in AI research about how much human guidance agents actually need. Do you carefully hand-engineer the tasks, the rewards, and the knowledge structures? Or do you build a rich enough environment, throw a learning algorithm at it, and let capability emerge? A technical report called Darwin Mobile Agent, published on Archive by a team of 8 researchers in May 2026, comes down firmly on the second side of that argument. The paper is explicitly guided by what the AI community calls the bitter lesson, the observation, most famously articulated by researcher Rich Sutton, that general methods leveraging scale and computation have consistently beaten approaches that bake in human domain knowledge. The Darwin team's proposal is to apply this lesson to autonomous agents by using the mobile phone's graphical user interface as a training environment. Their argument is that smartphones represent a genuinely complex world. Thousands of apps, constantly changing interfaces, diverse tasks ranging from messaging to commerce to navigation. If you can train an agent to operate effectively across that landscape without hand-labeling every task or engineering every reward signal, you are getting somewhere meaningful. The practical challenge they tackle is data collection speed. Reinforcement learning on real mobile devices is slow. You can only run one environment at a time on a physical phone. Darwin's solution is parallel cloud phone instances running asynchronously, which lets researchers run hundreds of environment interactions simultaneously and compress the time needed to gather training data. The roadmap the paper lays out has 3 stages, each focused on removing a different category of human prior from the system. First, how tasks are selected and ordered during training. Second, how the agent evaluates whether it actually succeeded at a task. And third, how it manages and retrieves memory across sessions. This work validates the infrastructure for Stage 1, policy optimization, but the harder problems, particularly autonomous outcome verification, remain open. Why does this matter? Because if the roadmap succeeds even partially, it points toward agents that can improve themselves at scale without continuous human supervision. That has profound implications for how quickly capable AI systems could develop, and raises serious questions about privacy given the sensitive nature of mobile interaction data. Darwin Mobile Agent is an early-stage infrastructure paper, not a finished system, but it establishes a concrete program for one of the field's most consequential open questions. Story 4, PEAR, Permutation-Equivariant Adaptive Routing Multi-Agent Debate. PEAR introduces a new inference time protocol for multi-agent LLM debate that dynamically reconfigures communication roles, to reduce positional bias and amplification of unreliable agents. The approach addresses key failure modes in fixed topology multi-agent systems without requiring retraining. Story 5, Beyond Fixed Budgets, Characterizing the Inelasticity and Limitations of Tree-of-Thought Reasoning Strategies. This paper systematically evaluates tree-of-thought to T reasoning strategies under varying compute budgets, model sizes, and problem difficulties, finding that different search strategies behave very differently under constraint. The results have practical implications for deploying reasoning-enhanced LLMs efficiently. Story 6, GOOG down 6% today due to two top AI researchers departing. Alphabet's stock fell roughly 6% after two prominent AI researchers departed for competitors, signaling investor concern about talent retention at Google DeepMind. The incident highlights the intensifying competition for top AI talent across major labs. Story 8, SkillHarness, Harnessing Safe Skills for Computer Use Agents. SkillHarness addresses safety risks in continual skill learning for computer use agents, specifically tackling prompt injection attacks and environmental dynamics that existing skill learning methods ignore. This is relevant to the deployment safety of agentic AI systems in dynamic real-world environments. Story 9, Darwin Mobile Agent, a roadmap for self-evolution. Darwin Mobile Agent proposes a roadmap for self-evolving AI agents using mobile GUI environments as a training ground, guided by the bitter lesson principle of minimizing human priors. The paper argues for agents that develop general, adaptive behavior through interaction with complex open-ended environments. Story 10, Specifying AI-SDLC Processes, a protocol language for human-agent boundaries. This paper introduces a protocol specification language for defining human-agent responsibility boundaries in AI-assisted software development, addressing governance gaps when AI agents participate as team members. It targets problems like prompt drift, fragmented access control, and missing approval gates.